Hello, everyone. This is Jason Rodriguez back again at ETS21, and we're excited to kick off this afternoon panel, Harnessing the Wind. As grid utilities and grid operators embrace both onshore and offshore wind, new energy policies and additional grid technologies are going to be needed to develop a more flexible grid architecture, optimize the energy portfolio and transmission systems of the future. And today, as we all know, there's aggressive targets to be net zero, whether it's 2030 or 2050. There's a huge challenge at hand. And today we have a distinguished panel to help dive into this, to these topics. So before we get started, just like to take welcome our panel and then have each one introduce yourself and just tell us a little bit about your company. So Ricardo, I'd like to start off with you.
Hey, thanks, Jason. So my name is Ricardo Marquez. I am a software solution architect for WindSim Power. WindSim Power focuses on providing grid enhancing technology for the industry, utilizing WindSim's over 25 years of computational fluid dynamics expertise. Right now, we are focusing on dynamic line ratings, technology that enables utilities to operate their transmission lines with more capacity. So it does this by modeling the wind fields over a conductor or over a long section of conductors, line sections, and then from the cooling effect from the wind, letting the utilities know how much true capacity is on their system. And this is a little different from what they're normally operating. They're normally operating as static kind of conservative assumptions, which are fixed throughout the year. So dynamic line ratings is, our flagship technology that WindSim Power is providing. A little bit of background for me, and maybe I can talk a little bit more about grid enhancing technologies and dynamic line ratings a little bit more later in this talk, but just a little bit about me. My background is mechanical engineering. In the past, I've done renewable energy forecasting. I spent like 5 years doing specifically on solar forecasting. And then after that, I went into more of a climatology kind of studies and actually even doing like flood emergency event software. And then I came back to WindSim Power to focus on wind resource software and also dynamic line ratings.
Thank you. And Carolina.
Hi, my name is Carolina Torres. I'm the Executive Director of Energy Industry Transformation for Cognite. Cognite provides a data operations platform for heavy asset industries, so oil and gas, as well as power and utilities, and renewables and manufacturing. And we help them to manage complex data environments. So really setting up a platform for being able to develop machine learning and AI solutions. So for the power and utility sector, a data operations platform would empower the utilities to build a pipeline that can reliably and automatically supply high quality data wherever it's needed from multiple different sources, bringing it together, contextualizing it, and then being able to develop solutions that can gain insights from that. And just my background, I'm actually from the oil and gas sector in the background. I spent 29 years working for BP, initially as a geoscientist, and then moving into more strategic and management roles until my last 10 years have really been around technology and innovation, digital transformation, and energy transition. And I joined Cognite in February.
Well, welcome. And Nicole.
Hello, my name is Nicole Bouchez. I am principal economist at the New York Independent System Operator in New York. We operate the wholesale electricity grid, operate the markets, and also have a real sort of planning function to inform about what is coming down the pipeline. And that's a lot of what I've been working on the last few years, is looking to see, we call it a grid in transition, what is coming down to us, what do we need to do on the market sides, and communicating a lot of information to all of you market participants and people who work with people who work in our markets, because there is such change coming through. One of the things we've really been focused on is New York has got very aggressive climate goals. As a matter of fact, our new governor, just announced yesterday that the solar energy goal, which was 6,000 megawatts behind the meter solar by 2025, was increasing to 10,000 megawatts of behind the meter solar by 2030. And that is just one of several changes as we have, as the climate change goals are sort of brought in closer, and a lot of this transition is really coming at us. So I'll look forward to talking about sort of what we see coming down the pipelines. Oh, and me, I'm sorry. I've been at the NYSO 18 years. I've was the market monitor for a while. I've moved into more market design functions for the last 10 years or so. Before that, I was an academic and a professor in London. So.
Wow. Well, thank you all again for being here. And to get started, Nicole, I'm going to pass it to you again and really help us kind of set that stage. And more renewables are coming online. You just mentioned these aggressive DER goals, wind storage, all of these things are in play, things you're looking at. So I just wanted to see if maybe you can crystallize some of what are these challenges we need to address today if we're going to be able to meet those targets by 2030. And I know that's a lot, but I'm just trying to see if you can give us some context of what do we really need to be focused on.
Yeah, it's a really exciting time, right? I mean, we have all, our industry is really changing, and we've been talking about it as, sort of akin to sort of the transformation that happened in the 70s, and then when the markets were created in the late 80s and early 90s, and were sort of, or conceptualized. We have a lot of changes coming, and one of the things that we've been, is the short term versus the longer term. And by short term, I'm talking about sort of, through 2030 and maybe even before then. And then the longer term is really associated with, we have state goals. The New York goal, for those of you who aren't immersed in New York goals, is to have 70% renewables by 2030 in the electrical sector. And that's, it's an achievable goal. It's going to have a bunch of transition. But then we have a zero emissions by 2040. And that's, a very different goal, especially because one of the things that we see that we will continue to need is flexibility in the system. And by flexibility, I mean resources who we can call to ramp up. Ramping down is not so big of an issue for us because our renewable resources are on dispatch in New York. So if we need wind or solar, wholesale solar, to dispatch down, we have a tool to be able to do that. But what we don't necessarily have as we transition to more renewables is resources that can ramp up and are emissions free. And so that's, for us, is sort of one of the big challenges. The other is transmission, because the areas where a lot of the renewable resources are getting built are not the same as the areas where the load is. And so it's sort of either the renewables have to be located closer to the load centers, which is a challenge, right, for New York City, where, that region where most of our load is, or the majority, our largest loads are. And then, or if you don't locate the renewable resources there, how do you get the energy to them? Because ultimately that's going to, now our governor just made an announcement as well of some two controllable transmission lines were coming. This has been in sort of the pipeline. We don't really know what's going to come from there, but it's more than just those things, right? It's sort of looking at transmission together. And really what we're focused in is the reliability of it. And that's where this flexibility, this availability of transmission matters. The other thing we've been looking at a lot is these extreme conditions. What happens as weather changes, as storm patterns change? And the meteorological conditions are really sort of, as we all know, sort of transitioning and sort of trying to build resilience into our systems. So Jason, that's a lot of what we're facing at the moment. If you want me to go on, I can, but I suspect we have lots of other important things to touch.
No, I think that was fantastic. So Ricardo and Carolina, I'd love for you guys to take that from the technology side. Obviously, there's the forces that are at play. But Carolina, maybe if you can start off, especially I think it's great that you come from that oil and gas background, because you've seen a lot of transition happen really quickly, and now you're stepping in and looking at this happen at the utility level. So what do you see some of these core technology gaps you think that we should be focused on to really kind of meet those challenges and help these markets develop?
So I think, as Nicole said, reliability and resiliency are really, really big challenges. And there's lots of different ways that we can go and attack that. I mean, I think storage is a big possible solution, but that could also be quite complex, right? So do we want to invest in big storage, centers, or could we come up with a solution where it's distributed storage, where potentially we could actually use consumer-based storage solutions like house batteries and even car batteries as sort of temporary storage that could be drawn on for the whole, right? And those sound like real pie in the sky right now, but I think that they're actually possible, and there are states that are out there and areas that are doing those kind of pilot studies, like in California, for example. They've got a pilot study looking at home storage batteries, home to grid solutions, for example, around storage. The other thing is transmission, as Nicole mentioned, and that's going to be a perennial problem everywhere. The load is not going to happen where you have the land and the space to be able to come up with your sources, right? So you got to figure out how to get it from A to B reliably. But I think more and more really, and this speaks to what Cognite is trying to address, and probably also what WindSim is trying to address, is how can you get on the WindSim side, and I'll let Ricardo talk more about it, but in general terms, how can you get more out of the infrastructure that you already have? And maybe get more capacity out of what you already have by using data and data analytics and sensors, other fourth industrial revolution type technology like sensors, robotics, AI, machine learning, et cetera, to actually optimize your existing systems. That's one. And what Cognite really is doing is the data system in this space is extremely complex. As it is, it's already extremely complex, where you have sources, multiple different sources, variable sources. You have load, you have weather, you have a lot of variables, and how you manage the data around those variables. The data is not a standard data universe. It is very non-standard. Everybody manages and deals with their data in a different way. And so you have to bring all of those different sources of data into one place. You have to contextualize it. You have to be able to, in order to gain the insights from it, you have to do quite a lot of work to operationalize that data. And that's what Cognite is mostly specializing in. I don't know if that's a good answer, but I want to actually hand it over to Ricardo, where he can talk about dynamic line rating, which is his specialty, because that's a technology that I think is super cool and needs to be talked about in this space.
Sure, yeah, Ricardo, would love your download and how that DLR plays into kind of these challenges and how we can. I think Carolina, you made a great point of getting the most out of the current system we have, because these are multi-million, sometimes billion-dollar investments being made. But Ricardo?
I think those were some great answers, Carolina, and I'll probably echo some of them, because the data, standardizing this non-standard universe is not just the data itself, but the transfer of the data and the reliability around that and security around that. But so I'm just gonna answer and touch on Anna's answers as well. So regarding the transmission and kind of the separation between load and resource, and so you do need some new transmission in some cases, and I'm kind of tying this back to doing more with the existing grid. So what dynamic line ratings does is it increases capacity of the existing grid by modeling the true capacity of the system. So as I mentioned before, static ratings are kind of contributes to phantom congestion, because static ratings are based on conservative fixed assumptions where there's almost no wind all the time, just fixed, no wind, and then hot ambient temperature. And, this is a conservative approach to rating your lines, because, without the information, then you just kind of go in the dark and you just kind of play it safe. But dynamic line rating sort of opens up the visibility, in this case, by providing the wind data, so that effectively you get more utilization, you can get more utilization, more capacity and utilization out of the lines. So I think this helps with using the existing grid more. And also, as you're building out new transmission, it's also important to consider that the capacity of your new transmission will probably be limited by your current transmission. So it also kind of it also helps with new transmission in this sort of way, or it can complement new transmission in this sort of way. I want to talk a little bit about weather changes and variability. And this is a little bit an aside from the dynamic line ratings, but Anna, you spoke a little bit about the resources and that they're variable. One thing that I see, or that kind of was experienced in California, was sort of the effect of geographic smoothing. So as you put more, say, solar out there, yeah, at first you see 15 or maybe 20% variability, but as you put more and more locations, that variability is really going to be about 5% or something like that of the penetration. So it kind of gets better, as you put more resources out there. So it's sort of a benefit or a problem that starts to reduce as you grow that out. I'll probably speak a little bit more in terms of the dynamic line rating, but yeah, at the moment, this is what I have.
Okay.
This is all I have to say.
That's fine.
Mm-hmm.
Yeah. No. Thank you for that. So Nicole, I think there was a lot covered there. So just quick, because I know this is a lot of what you're working on. How does this play into, or make it more difficult to do the market balancing functions that, and what ISO really has to do as they're kind of blocking and tackling every day? More data, more distributed resources. You mentioned the flexibility goal. How does that play into making that whole function much more challenging?
It definitely does, but I think it also gives us a real opportunity to get the markets to really focus in on what the system needs, and then to use that and therefore have the resources, getting revenue when they're providing value to the ISO and to the wholesale grid. One of the things that we see as the resource mix shifts is that we are looking specifically at the products we currently do or solve for in New York, and do we need to change the quantity of those? Do we need new products? And this is one of the things that we're working through. We've worked now for probably a year or two with our stakeholders, and we're sort of in the middle of that discussion. There are some functions that traditional fossil-based generators have so much of that it hasn't even been sort of priced, right? Because there's just so much of it on the system. But as those resources transitions out and new resources, new renewable resource transition in, are those are those things that we need to look at more specifically, or are they really not needed? So that's sort of the discussion that we're having. One of the things I wanted to just mention was that I think it's wonderful that we're getting batteries, and on the systems as well. One of the challenges for us is, and I really think the batteries will help with the diurnal sort of day night sort of 24-hour or 48-hour patterns we have. In the longer term, one of the things we are thinking about and don't know what the answer is what happens when we have 3 weeks with low wind, and especially if that happens at a time where there's cloud cover, right? And those are the real challenges that we see coming up. And I am afraid I don't have a good answer for you. I'm hoping that, luckily we have time to solve this one, but this is one that we need people to think about in terms of what new technologies, what new resources could come from that.
Thank you. Thank you. And Carolina, there was a question just came in from the chat. So I would love to get some audience interaction there. So would you like to take that one?
Yeah, it says here we have a question from Dan, who is a CEO of United American Ventures. They're looking at small wind turbines. I guess this is sort of residential solutions. And I'm not an expert in this. As I said, my background is in oil and gas, but I lived in Europe for 8 years until a few years ago, working for an oil and gas company. And one of the things that I noticed or feel, an observation that I have, is that Europe feels a lot more ahead of us in this space. In Scotland, where I was living, for example, it was very common to have residential wind turbines. And similar to some of the things that we have here in New York and Massachusetts and in the East, where there's government incentives to get solar thing on your roof, and then you feed back to the grid, or you get some sort of a incentive or a low price for being able to actually supply and be a prosumer, a producer consumer. In the solar, I don't know if that's very common in the wind in the US, but it is very common in Europe, and much more common than here than what I've seen. And I think it's a really good solution. But again, getting back to the whole sort of complexity of data, when you have prosumers, whether it's solar or wind, that's just one more sort of complex, or storage for that matter, which I mentioned earlier. It becomes this incredibly complex distributed system to manage, and you need to figure out a way to operationalize that data. You have to automate it. You have to have templates for managing that. So it's not something that humans are going to be able to keep up with real time in the way that we have been in the past. We've been very spoiled to have this nice hydrocarbon, single sort of system. It's all one way. It goes from the source to the consumer. And now we've got, a two-way system where consumers are also producers. And that's quite an interesting challenge as well. Yet one more variable.
Yeah, which brings up a good question that maybe Nicole, you could take the first stab at this. So the complexity is only increasing, right? So generators, ISOs, utilities, and now communities, third parties need to be work together. So what are some of the ways you think they can better work together to help solve those? And maybe that's policy, maybe that's more working groups. What are some of the programs you see out there that could help bring that further collaboration?
Well, good news is that we have started a lot of those discussions. So we have collaborative groups with what we call the joint utilities, for example, to talk through some of those, issues of who's collecting what data, how does that data need to be transmitted? I mean, because traditionally the wholesale markets sort of focused on the wholesale markets, and the utilities and the distribution companies focused on the distribution. And you're right that there is a lot of discussion, but there's also a lot of bright lines, I guess, between whose data is it and how important is it. I mean, the person who loves to look at data in me, right, would love to have instant access to every single piece of data because there's always something interesting in them. But do you really need that as part of what you're solving? Or is there, another way of dealing with that and having other entities or other people have access to that data and making sure that you have access to the data that you need? And in many cases, that's rolled up data. And so we spend a lot of time, Caroline, I think you would find it very at home, talking about data and what data is needed where, basically, and why, right? So I think we tend to always want everything, but in this world of so much data, sometimes being smart about that data is really the best way of going.
I totally agree. I mean, I think people think, oh, we just put all the data in our data lake and, then everybody just pulls out what they want. But the problem is you get overload. And if you don't have some sort of a curation or a way of like actually understanding what is relevant to what I'm trying to solve right now, it actually becomes counterproductive to have so much access to so much data because you don't even know where to start. The curation and the relevancy, the establishing of relevancy for different problems is actually a big part of the solution. You can't just, oh, we'll put all the data in one place and everybody gets access and we're done.
Great points there. Ricardo, I wanted, because we're just to frame it a little more, see if you had any thoughts on terms of what are some of those policy, we know there's working groups, but are we seeing that same movement or maybe what's lacking on the policy collaboration to be able to give all these different stakeholders better better guidelines and rules to shape these policies needed for this rapidly evolving market?
Coming from a technology vendor, so I guess, the challenge is that you're offering a technology to entities that have a traditional approach to doing things. So they lean on, on the reliability of the grid and managing this, and this is a top priority. So anytime that there's new technology, new data, it could be kind of confusing, overwhelming, and maybe even risky. So from my perspective, what I would like to see more is just that the data is just, number one, becomes a little bit more available to them, more readily available, without them having to feel the risk, the operational or the financial risk of it. So I think this is where policy can contribute and is contributing. So FERC has a recent NOPR. Excuse me, I forget what NOPR stands for. Is Notice of Proposed Rulemaking. So I think, so in that FERC NOPR, what they're doing is they're looking for ways to incentivize the adoption of new technologies. And anyway, so this is, I think, overall big picture, I think what they're doing is they're lowering the barrier for vendors to come in, to be able to provide some of these data so that they can get more familiar, before they feel like they're encountering operational or financial risk on acquiring new technologies. So, I mean, this is sort of the hurdle, and I think FERC has taken big strides lately in achieving this incentivization structure, so that it's sort of reducing the reducing the barrier, so that they can just adopt the technology, through pilots and stuff like this. So this is what policy is doing now, and they've made a lot of progress.
Yeah, that sounds like a good parallel to what you see happening at the local level with states and the PUCs, and really trying to figure out this, how do we move technology and new structures and rules where there's so many new technologies that can help utilities and now markets solve these problems. So Caroline, I wanted to now have you, if you can a lot of the work you guys do is on these data challenges. So what do you guys see that are those challenges that lie ahead in the near term, specifically in adopting renewables as they're predicted, as Nicole had mentioned. Now we're looking at a rapid clip of growth. We all know data is a challenge, but what are the big other challenges you see out there?
Sure. At first, actually, I just want to tie something that that Ricardo just said to Dan's question around, are we going to have big central wind turbines only, or is it going to be possible to have like residential, single point distributed type systems on wind? And really, the answer is it's really going to be about policies and regulations, right? Because part of the reason why Europe is quite a bit ahead of the US in a lot of these places is because of, the European Union and the UK have put a lot of policies and regulations in place that incentivize certain behaviors. So, it's hard to answer your question specifically. Yeah. Is it all going to be, centralized wind generation, or is it going to be distributed without really, it's such a big question mark what's going to happen in the future. But if getting back to your question around data challenges, there's major challenges with regard to reusability of data within and across applications, because, as an operator, you have to be able to operate data from multiple sources. So, from the DLT sensors to maintenance records to weather forecasts, energy suppliers, central or distributed, and the demand, all of that has to, they manage and supply data in different ways, and the operator has to take that all and collate it and add meaning to it and understand the relationships between it, and then generate some algorithms that provide insight to help make decisions. That's basically bottom line what needs to happen. And as we mentioned, we all talked about before, there's not any sort of industry-wide data standards that simplify the whole process and make the whole thing work seamlessly. It's all full of friction and translations and modifications. So to build and maintain, some sort of analytical platform across all these data and to aid in the optimization and decision-making that needs to happen, it's where the cost and the complexity comes in. Data operations is kind of an emergent industry in and of itself, like how to operate data, and it's not really, I think, efficient or really the best solution for each operator or utility or power utility or even like wind farm supplier or what operator to build their own data operations platform. It's very time consuming, it's very costly to maintain. And so it's almost like, different companies like Cognite that are coming in and trying to create that solution. I mean, it's kind of like if you imagine every enterprise or company out there having to invent their own Microsoft Office 365. That's not a good solution, right? It's good that we have Microsoft that does that and like continuously maintains it and improves it and, is constantly building a toolkit around it. So it's not a once and done thing. It's not like you build your data platform and then you're finished. It's over. Okay, the platform's there and all the data's there, because the data is dynamic. So it's a dynamic system through mergers and acquisitions, different, you can add EV stations to it. New technology comes in. Right now we're focusing on wind and solar, but how do we manage hydrogen when that's coming along? So, how there's a continuous evolution. And the competitive advantage is going to go to the entities that can evolve quickly and have flexibility with regard to their data operations.
Thank you. You had another question come in and wanted to see if someone wanted to take a stab at it from Jan. Thank you for the question, Jan. Europe is betting big on green hydrogen production from offshore wind. Does the panel see opportunities for the US? Nicole?
So I think there are opportunities, and this is exactly what I mean when I mean sort of dispatchable, flexible green resources, right? Because that is one of the ways of doing it, which is you produce something that can then be stored. I think hydrogen, I think there are challenges for the US in that I'm not a hydrogen expert, but I understand that moving hydrogen is challenging, however you decide to do that. And Europe is far more compact than the US is, or even the East Coast of the US is. And so, but there are also, some entities who are exploring sort of making synthetic hydrocarbons out of green hydrogen, right? So can you make synthetic methane then with a carbon capture, of course, component to it? So these are all sort of these technologies that we have to explore because in the short run, I think there's a lot of promise for hydrogen because a lot of power plants can actually burn a blend of natural gas and hydrogen. There are some pilots that are now starting up to really sort of explore that in the US, but in Europe that has also been explored. And it's a little bit more challenging on the distribution system for the natural gas system. People's home heating can't necessarily deal with blends, but the power plants, a lot of them were designed for blends or can be not too difficultly retrofitted to burn blends. But it's those types of, Jan, those are exactly the types of new technologies that we need to explore because there are probably aspects of it that we haven't even thought of along the way. So
Thank you.
The rest of you.
Thank you. Now, because I think you've all touched on this in a little bit, so would love your different perspectives on the changing weather, right? There's more frequent weather, climate change. This is NY Climate Week, as many of you know, and there's several ways to tackle that. So how do we take into account like the market design operations when these severe weather events are occurring at higher rates? And we'd love for you guys to take this from your different purviews to offer some insights to our audience who all have to take this now into their planning and strategy. And Carolina, maybe we start with you there.
So, I mean, I hate to sound like a broken record, but I think it's really important that you have a good data platform.
Yeah.
So, I mean, a good data platform would have tools that automate the data contextualization and enable the building of robust reusable data models that accelerate the way that applications can be deployed and how the analysis can be done. I think I've read different statistics, but something like as much as 80% of time is spent on data management and data collection and data cleansing and data manipulation in order to build a sort of a predictive model. And then when you get an extreme situation, that model might not be applicable and you have to add additional information to it, and that's time consuming. And so our ability to respond quickly really depends on having that kind of a good platform that has that kind of flexibility to it. And yeah, I'll just leave it at that. And give
just a quick follow up there, if you don't mind. Can you because Cognite does a lot of this work across industries. Maybe what are those core principles that make a good data platform? I think that might be helpful. Sure. From your perspective.
So the automation of data contextualization and the ability to merge and fuse data from multiple sources into something meaningful with relationships. The platform, in order to enable a technology like DLR, you have to have the ability to integrate multiple data sets with different standards and data types, and to be able to facilitate the scaling of that across, say an entire transmission network, but also has to be flexible enough to incorporate new data as it becomes available. So flexibility and how the algorithms are written is super important. And then the last is, I think it's super important that the data platform not become a data silo itself. So it should be an open system, that exists in concert with other tools and other systems, and that there should be an emphasis on interoperability. Because that's really that's the name of the game in this. It's all about interoperability, data operations.
And Ricardo, any input or asides to add on to that point?
Yeah, I like everything Carolina said. Let me take a step back and just define resiliency in my own words, I guess. So resiliency is the ability to anticipate, recover, and minimize the impact of severe weather events. I think that's kind of a pretty good definition. So recover and minimize the impact and anticipate. So I think, you know, between being able to forecast properly, but also have ways, you know, if there's some sort of outage somewhere, that you can still utilize other assets to their capacity rather than, you know, doing some sort of rolling blackouts or something like this. So being able to recover, and so I don't mind sounding like a broken record, but again, like dynamic line ratings can help with this better utilization. This is the resiliency aspects are kind of my favorite features of dynamic line ratings. You know, sometimes you hear from industry, oh, well, you know, not all lines are thermally limited. Yeah, not all the time. And maybe they're not contributing to congestion, you know, day ahead, you know, day-to-day sort of operations. But, you know, when there's, you know, extreme events and, you know, you really need the capacity, then, you know, you can't really, you know, it's only to your benefit to adopt some of these technologies.
Thank you. And Nicole, yeah, going back to the market design, I think actually Jan, who posed that question in a panel earlier, you know, one of the thoughts that came up is the days of looking 10 years back of data to forecast the future are probably not going to be here now because of these severe weather events that are occurring. So we actually have maybe less data to try to figure out what's happening in some instances in areas of the U.S. and across the world probably that are getting impacted more by severe weather. So how does that play into some of your market design thinking of how you guys look to the future?
Yeah, no, you're exactly right. I mean, one of the things we've done is moved up sort of the future, the past that we look at to predict the future in our load forecast, for example. We don't go as far back as we used to for exactly that reason. The other thing we've done is really sort of looked and artificially and sort of on an analytical side, stressed the system with different scenarios. So we have a study we did last year called the Climate Change Phase 2 study. Wonderful titles. We're really good at titles. But it really did exactly that. It said, okay, you know, in a future with high renewable penetration, including offshore wind, you know, what happens when a hurricane comes through? What happens when an ice storm comes through? What happens when there's an extended heat wave? And we then went through looking at operationally sort of what happened as a consequence of that. And, you know, as expected, you know, there are concerns there. But there are also things we can learn from those types of exercises. And so I think it's important for everybody in all of their businesses to start doing those thought experiments. And, you know, what can you learn from looking at this? I don't know that we have answers, again, to all of those questions, but knowing and seeing, you know, what is it? And this is, you know, goes back again to the themes that I have, which is, you know, transmission matters on the wholesale grid. Flexibility matters, you know, especially with unusual outcomes. You need to be able to have sort of resources that respond. And so those are sort of the things that we got out of these studies. They are public, so they're fairly easy to find on our websites, but feel free to reach out to me if you're looking for them.
Got it. Yeah. So wow, the time went by super fast, as you all guys know. So the title of the panel was Harnessing the Wind, but it's also in the context of these winds of change that we are all managing through. We touched on the data and the importance of a good data platform, of resilience and policy, and how that really plays into it. But we also opened up and left a lot of open-ended questions that are yet to be answered. But I think that's why it's important to bring thinkers as yourself and doers, so that the industry can go back and they have some better idea of how to address these problems. I can't thank you all enough Carolina, Nicole, and Ricardo for joining us. Sorry, our time seems short today, but we do appreciate your time and being a part of ETS 21. And thank you all of you out there, and stay tuned for your next session.
Right. Thank you very much. Thanks for having us.
Thank you.
Thank you.